Okay, Algebra 2, you should have a sheet that looks like this, solving systems of equations. This is another section that we did probably way back in chapter 1 when we did linear functions, but this is another one that's good review because this shows up a lot. So on the front side here, there's 6 problems that we are going to go through together, and then I'm not going to make you do every single problem on the back side here, but what I'll do is throughout this video, we'll do a problem and then I'll maybe assign one of these, and you'll just do it as the video goes along. So just kind of be prepared for that. So number 1, what they're having us do is these two functions are linear functions. So if I were to graph these two guys up here, even though they're not in slope-intercept form, they will still look like two lines, and what we're trying to do is we're trying to figure out where those two lines intersect. That's what we're doing when we're solving systems of equations. We're trying to find where the two places intersect. Okay, they are proposing that the place where they intersect is the point 6, negative 2, and we're trying to see if that's true or not. Okay, so what we do is we need to plug those back into the equation to see if it works out. So 6 is going to be the x-coordinate, negative 2 is the y, so we're going to plug this in. 4 times 6 minus 3 times negative 2, and let's see if that comes out to be 30. Let's see if that checks out. Okay, 4 times 6 is 24. Do as much of this in your head as you can. Try not to use a calculator. Negative 3 times negative 2 is positive 6, so we have 24 plus 6. That is equal to 30, so we are good to go there. Okay, now, I can't just stop with the first equation. I have to make sure that it plugs into the second equation also, because even though it works for the top one, it may not work for the bottom one. So this is a positive 3 here. I don't know if you can see that very well. That circle kind of, or my punch kind of got rid of that, but that's a 3x, so I'm going to plug 6 in for x, just like I did on the top one. Okay, and we're going to see if this checks out. So 3 times 6 is 18. 2 times negative 2 is negative 4 equals 22. Okay, now 18 plus 4 is equal to 22. That's true, but 18 minus 4 is 14 equals 22. Not the case. Okay, so what's happening here is these two functions maybe probably do cross each other, but it is not at the point 6, negative 2. So let's do this. 6, negative 2 is not a solution for this system. Okay. If it worked for both, then it would be a solution, but it's not. Okay. All right, this next one, they want us to solve the system of linear equations by graphing and then state the solution. So I want to graph these two linear functions, and what I'm going to do to start with is I want to solve for y. I want to get them in slope-intercept form. Okay. So I'm going to bump this 6 to the other, or excuse me, the 3 to the other side. So plus 3 plus 3. So that will give me 3y equals, and it's negative 6x plus 3. I cannot add those two together because one has an x and one doesn't. So I'm going to write it just as negative 6x plus 3. Okay, dividing by 3 on everything, that gives me y equals negative 2x plus 1. Okay, and that's my first equation that I have. So let's go ahead and graph it. So I start at 1, and then the slope tells me I go down 2 over 1. Down 2 over 1, down 2 over 1. I'm going to drop a few points in here just so that I make sure I get this graphed right. Okay, so there's my line. Okay? All right, the second one, I want to do the same thing for. I want to solve for y. I'm going to do this in a different color. Solve for y. So I want to get rid of this x first. So I'm going to subtract the 2x because this is a positive 2. Okay, and if I subtract 2x over here, okay, this 2y still has a negative in front of it. It's still negative 2y because the 2, or the y is what's negative. It's not the x that has negative. Over here, I want to say equals, and I'm going to put the x first, so negative 2x minus 14. And then divide by negative 2. Divide negative 2, divide negative 2. Okay, so y equals negative 2 divided by negative 2 is positive 1x. Negative 14 divided by negative 2 is positive 7. Okay, so I'm going to start here at 7. 2, 4, 6, 7. And I'm going to go up 1 over 1. Up 1 over 1. Okay, this is a positive slope, so up 1 to the right 1 is how I'm going to do this. And I'm going to, I can already kind of see where they're crossing each other. Okay, and it is at this point right here, which looks like it's at negative 2 comma 2, 4, 5, negative 2 comma 5, I think is where they're crossing each other. So now I could check that by plugging this back in, just like I did in number 1. I could check that, and it should work out with both of the equations because that's where those two things are crossing each other. Okay, now I don't want to have to graph every single time, so what I'm going to do, I have a couple other options. I can either use substitution or I can use elimination. Okay, so what we're going to do for each one of these, this one we're going to use substitution for, and then this one we're going to use elimination for, okay, because those kind of go really nice. So substitution, when I'm substituting something, I have to have something solved for. Okay, I don't know if there's a number here, but I went ahead and switched that and made that negative x, so it comes out nice. It almost looks like there's a 2 there or something. But change that little circle and make that negative x plus y equals 5. Okay, so what I'm going to do to substitute is I kind of have an x and a y and an x and a y, and what I need to do is I need to solve for one of those values, either the x up here, the y here, the x here, or the y here. Get it by itself so that I can plug it into something else, okay? Now we need to decide which one would be the easiest one to solve for. So in the top equation, I have negative x and I have positive y here. So it might be easiest just to solve for this y, okay, and add the x to the other side so I can get rid of that negative. So if I add x, I'm going to add x here. So I have y equals, we'll write that as x plus 5. Okay, that's what he will look like. Okay, then we can now, since he's solved for, we can plug him back in for this y. We can replace that y. Okay, so I have negative 4x plus 6 times y, which I'm going to put x plus 5 in for, equals 12. Okay, and then next I distribute that 6 through, so I have negative 4x plus 6x plus 30 equals 12. Okay, and then I'm going to kind of combine like terms and do some things. So negative 4x plus 6x is 2x. And I'm going to go ahead and I'm going to subtract this 30 to the other side, which is going to give me negative 18. 12 minus 30, negative 18, yes. If I divide by 2, x is going to be negative 9, all right? And I'm almost done. I have to solve for the y coordinate now. So I have up here that y is equal to x plus 5, or y is equal to negative 9 plus 5, okay? If I put those two together, negative 9 plus 5 is going to be negative 4, okay? And then the last thing that I'm going to do is write that as an ordered pair. So I have negative 9 comma negative 4. And why do I care about this point? Like, what happens here? Well, this is the point where those two functions are going to intersect with each other, or they're going to cross each other. Okay, they're going to look like this. So I solved that by using substitution. That might be easier than actually having to graph them and go to all that work, okay? Number 4, we're going to do elimination. So I want to be able to add these two equations, top and bottom, together and eliminate a variable. So I have 2x and 10x. If I add those together, that will make 12, okay? And then I have a negative 3 and a positive 1 there, okay? And those won't cancel out either. So what I have to do is I have to change one of the equations, or multiply one of the equations by something to get it to cancel out. So I'm going to pick on the y's here. You could choose the x's if you wanted to, but I'm going to pick on the y's because I have negative 3y and positive 1y, okay? If I can change this bottom equation to be a positive 3 and a negative 3 will cancel. So I need to multiply this guy by 3 on the bottom, okay? I'm going to rewrite the top, 2x minus 3y equals negative 1. We're going to leave him alone. But the bottom equation, let's distribute a 3 through. So 3 times 10 is 30. X, 3 times y is 3y, and 3 times 11 is 33, okay? In that case, my y's are going to cancel out, and I'm left with 32x equals 33 minus 1 is 32. That's really nice. Divide by 32, and I get x equals 1, okay? So I've solved for my x, and now I need to solve for y, okay? So let's go back up to, I don't want to deal with negatives. Let's go to the second equation. Let's do 10x plus y equals 11. So I have 10 times x, and we said x was 1, plus y equals 11. Okay, 10 times 1 is just 10. And then to get y by itself, let's subtract 10. So y is equal to 1. So I have the point 1 comma 1, and this is going to be the place where those two lines are going to cross each other. So I've solved for the same thing, but just using a different method. That was elimination rather than substitution. Okay, All right, 2 left. Now, sometimes you'll end up with weird answers. So infinite solutions or no solutions, those are things that can certainly happen when you are graphing stuff, and we'll talk about what those look like. This should all be review for you, but if it's not, we'll go through all that stuff again. So infinite solutions. This system is kind of set up ready to go for us using substitution because the y is already solved for. So what I can do is I can take this 17 minus x and just plug that in for y. He's already kind of solved for. Okay, so I'm going to do that. I have 3x plus 3, and that y in place of him, I'm going to do 17 minus x equals 51. So that's where he goes. Okay. Next thing I do is I distribute through. So I have 3x here. He's just tagging along. 3 times 17 is 51, I think. Minus x equals 51. Okay. And then what I have going on here is that, let's see. Oh, shoot. 3 times 17 is 51. 3 times negative x is 3x. There we go. You guys would have caught that, right? If we were in class together. So what I have going on here is if I combine my terms, I'll have 3x minus 3x, which will make that go away. Okay, so then I will have like 51 equals 51. And you can certainly subtract the 51 over, but when I have 51 equals 51 and I don't have an x left over, we kind of look at this and we say, okay, well, when does 51 equals 51? Well, 51 is always equal to 51, right? So this is always true, which means I have infinitely many solutions. Okay, there's going to be an infinite number of solutions. So what does that look like if I have two linear functions if there's infinitely many solutions? Well, that just means that the one line is on top of the other line. Basically, this is asking for how many places do they touch each other. Well, if they touch each other at an infinite number of places, they're going to be the same function. Okay, so they're the same line, okay. That's just kind of how this works, okay? And in fact, this second equation, if you would divide everything by 3, you would end up getting, y and x and 17 as your numbers, okay? All right, so let's look at no solutions next. Okay, last one. So this one, let's go ahead and let's do some elimination here. So 3x and 3x, if I add those two together, that makes 6x. But if I want to cancel those out, I can multiply the bottom equation by a -1. Okay, so the top one is going to stay the same, 3x plus y equals 4. And the bottom one is going to be -3x minus y equals -1 times -1 is +1. Okay, so now I notice that the 3x minus 3x goes away. And y and -y, that also goes away. Okay, so what's left over here on the left side is 0. So I have 0 equals 5. Well, 51 is always equal to 51, but 0 is never equal to 5, right? This does not happen. That's not true. So this will be no solutions, okay? And what does it look like when there are no solutions? Well, we're looking for the number of places or the places where the two lines cross each other. And if they don't cross each other, what will they have to look like? They will have to be parallel to each other. Okay, so maybe the two lines look like this, where they're never touching. That's a scenario where I have no solutions. Okay, and in fact, that's consistent with what's up above here, because if I would move this 3x to the other side, I would end up with y equals -3x plus 4. That's what he would look like. Same thing if I move this x to the other side, I would have y equals -3x minus 1. Well, we know that those two things are parallel because they have the same slope, but they have a different y-intercept. So they're not exactly the same line like these were over here, but they have the same slope and a different y-intercept. So that's why there's no solutions. Okay? All right, so those 6 problems, those are good to review. Make sure you know how to do each one of those, and we're good to go.